Do you want to make your SQL query fast? Then create an index. But are you sure that SQL Server will use that index? Do you know how SQL Server will choose an index for a query? I'm Said. In this video, I'm going to talk about the SQL Server and indexing. I'm using SQL Server as a database, and I have one database with one table in it called test. This table contains 5 columns, ID as a primary key, 3 columns, A, B, and C as a string and varchar, and also we have one created as a datum for each row. Okay, in this video, I'm going to focus on these 3 tables because mostly in our tables, we have some string columns and we want to see how we can create effective index on them. Imagine that you have one API in the project and it takes time to run. Everyone complaining, oh, okay, why this API is slow, try to optimize it. And your project manager, your team lead, come to you and say, hey, why this API is slow? Optimize it, please. And you as a developer trying to investigate the code. When you're checking the code, there is only one simple database query. So you realize that the problem is on the database side. So imagine that here your query in the API is like this. You're trying to query on call A and call B and call C. And this one is taking time to run. Let's see. You know that if you want to see the exact time for the SQL Server execution, you can turn on the statistics time on. By running this query, SQL Server will give you the time for the execution. So if I run it first, right, and then I want to run this query. For sure, there is no records for this kind of conditions. But here in the message tab, you can see that this SQL Server execution time takes 236 milliseconds to run. It's too much. Now you want to optimize it. Okay. Whenever you want to optimize a query, first place that every developer wants to check is execution plan. So here you can turn on the execution plan. For checking the execution plan, when you enable it, you need to run the query again, and it will add another tab here called execution plan. Okay. If I want to see what is in our execution plan for this query, here we have one clustered index scan that takes 92% of whole execution time for this query. And this is not good. First, there is 2 words that you need to care when you want to check the execution plan. Okay, if you don't know how to use the execution plan, please leave a comment for me. I will create another video about how execution plan work, how you can use it, and the other stuff. But here we want to focus on the indexes part. In this part, SQL Server says clustered index scan costs 92% of the execution time. So this is the problem actually. This is the problem of our query and we need to fix it. What is this? What it means actually? A scan, it means it will scan every single row in the table for finding appropriate result, which is not good. Another one is seek, index seek. Index seek is a good sign in the execution plan. Every time that you see such a index seek in the execution plan, it's a good sign. It means SQL Server or database engine, when it tries to find the result, it's exactly point to that index and it will be very fast. So we are trying to achieve that point for getting the index seek. Another interesting point for the execution plan, if there is a problem with indexing the query, execution plan will suggest you missing index impact 99% of the query. It's suggesting please create this non-cluster index As you know, in the SQL Server, you have only one clustered index, usually created automatically when you create table on primary key, but you can create many non-clustered index. Anyway, here create non-cluster index on these 3 columns. So execution plan trying to say, if you create this index, it will impact 99% on your query. So that's good. Let's create it. Here is the syntax for creating non-cluster index. Best practice for naming the index is starting with ix as index, table name, and then the columns that you want to create index under. So here, call ABC, and then I want to create this ABC as execution plan suggested for us. And the order, the sort index by default is ascending. So if you don't specify sort for index, it will ascending sort. And then if you want to put something like this column A, I want to be sorted descending. So you can put the descending one. Okay, let's create the index. Okay, right, we have the index here. Now let's run the query and check the execution plan again. Now we can see that there is index seek, okay, which is a good sign for our execution plan. It says database engine, when it wants to run the query, it will seek for new created index for those 3 columns, and it will take 50% of the execution time. There is no new suggestion for missing index. Index is good. And also here 50% for key lookup. If you don't know how it works, please leave a comment. I will create another video for a whole execution plan. But in short, this key lookup will cause these selected columns in the select one. So for example, if you try to select call A for the select columns and run the execution plan again, you don't have that key lookup, right? That's about selecting the stuff. Okay, let it be like that. If I run the query again and see the execution time, let me put it in new session to not using cache, and I need time on this session. As you know, when you open the SQL Server, every tab is a separate session, and it will have separated information about this session, these queries. So if you want to run this statistics time for this session, you need to run that query again. Okay, let me run this one again. It takes around literally 0 millisecond, less than 0 milliseconds. Why? Because it's using the index. Maybe 1 or 2 milliseconds. It's still, I think, using the cache. But the point is, by creating the index, there is no time for scanning the table and scanning the index for getting those records, right? But we have a good index on table, and then SQL Server run it very fast. So done. You did your job. You can say to project manager, okay, I optimized the API. Run, everyone happy. But that's not the end of the story, guys, okay? Because when you are create the index on your table blindly on the fly, whatever the execution plan suggested to you, you should not follow them. Why? Let's see. This execution plan currently is good. It's nice. But what is the point here? The point is you create new index. So currently you have 2 index on your table, right? The best practice is having 4 or 5 index on your table, not more. Why is that? Because, okay, indexes is really good for query on the data. But what happened on the write operation? So for select stuff, really good. But for update, delete, insert, index is not good. Is a downside of the indexes. on write operation. Because, for example, when you are trying to update a record in your table, subsequent indexes needs to be updated as well. So it takes more time when you are trying to do a write operation. So for this reason, it's not good for creating many indexes on the table. Just keep it 4 or 5. Okay. So for this reason, it's really important when you are trying to create this kind of composite index on the table. So let's see what I mean. You have these indexes, but how SQL Server select one index on your table? When you have one index on 3 columns and you are trying to query with different word class, in which situation SQL Server will select this index for running the query? For example, in another API, you have only this word class, let's say like that, on call B and C. What do you think? SQL Server is still using the index on it or not? Think about it. Let me run the query again and see the execution plan. Now, if I run the query again, you can see we have the bad sign again. Index scan. This scan always is bad. Trust me. Every time that you see table scan, index scan, be sure that your query is not good. Okay? Again, index scan will take 93% of execution time. It will cost 93%. And again, we can see that execution plan suggesting another index. And again says, okay, if you create this index, it will impact 99%. What the hell? So you want to create another index? That's not good. For this reason, I say, please try to check all of these scenarios in your database and also in your application. What is the best practice for you? It's not good idea for every time this query takes time. Let's run and see the execution plan. Okay, it suggested this index. Let's create, done. So this kind of things is only work for single query. But what's the reason behind it? The main reason for this video is talking about how database engine will select one of the indexes and put that index to the query when it try to run the query. So the point is here, imagine like that. If you have, for example, let me run another query. Always please try to set top 10, 100, put it on the select. Because for example, we have more than million records here. If you simply select star from table, it will get all of those records, and which is not good, really. So we have this kind of values in these 3 columns, right? The question is, how SQL Server creating this kind of indexes? In very high level, if I want to tell you, so let me select one, call A, B, and C. So now, if I want to copy with headers and put it here, okay, good. In very high level, when SQL Server trying to create an index for this specific row, it will put all of these values and concat them together. For example, for this specific row, it will create an index like this. First value of the call A, call B, and C. Something like that. It's not exactly like this because it will not create plain text, but think about this. So we have A, B, and C, right? Always from left to right. For this reason, call B and C as execution plan is saying that I have to scan the index. I cannot seek it. Why? Because it will only contains the call B and C. So for example, here I have these values on the where clause. But what's the problem? The problem is SQL Server cannot find this index inside the main one. But if you're trying to put the columns like the A and B, it will use the index. So for example, if you are trying to query for this value, because it started with this one, it will use the index. You say no, let's see. So if I want to remove the call C, call A, and let's run the execution plan, you can see this is index seek. Index seek is a good sign, I told you. It says, okay, I'm using that index created for those 3 columns, and there is no suggestion for creating new index. That's good. I don't know you got the point or not, but the point is always it's from left to right. If you have 3 columns, A, B, and C, you can actually, let me say like that, from left to right. You can use call a single one, and it will use the index. Execution plan, index seek. Or you can use A and B. B, again, yes, it's index seek, or all of them, the 3 one. So that's the point for the SQL Server. Exactly for this reason, another point for the developers that maybe they don't care about how SQL Server choosing the index for the query. That's really important. Maybe you are a .NET developer. You say, okay, I'm a .NET developer. I'm not a SQL Server developer or TSQL developer. But that's matter for your job. As a backend developer, at least you should know the basic of the SQL Server queries. Basic means the indexes, the operations, all of these kind of queries on tables. But here is one of the most important things, in my opinion, that every developer should know about it. Otherwise, you cannot, when you are writing the query, you should keep in mind, if I put this where clause here in my link query and it will translate to the SQL Server queries, is it use the index or not? And another point that I wanted to add here is about the like operation or like query in the SQL Server, and it's equivalent to the EF when you are trying to use the EF core. When you put the contains, something like a string column contains, it turned to the like. So let me create a single index here. You can create index ix test call C, for example. Add call C. So we have one index on the column C, but what happened? So maybe for another query, you create an index on column C, and you are happy that this index will fast the query. But no, keep in mind that when you are deal with the SQL Server or any database, this kind of tricks are important. For example, you would say from test where call C equal something. And if I enable the execution plan, run it, fine. You can see that there is index seek again. I'm really happy when I see this seek operation in the execution plan. But that's not the end. What happened, for example, in the EF core, if I want to write the query here, for example, you have users where x dot username that contains C#. entity framework will translate this query to this one. So for example, if in the EF core you are trying to write this query, table test where call C dot contains C sharp. EF core will translate this link query to this thing. Select star from test where called C like this operation and C sharp. It will use this query for running the query on the database. Let me remove these lines here. If I run the query again and see the execution plan, again we have index scan, unfortunately. Why? Because if you remember, when SQL Server creates the indexes, it will put the values from right to left. So this contains will not use your index. When you create this index on the call C here, it doesn't matter. If you are trying to use the contains, it will not use the index. It says, I have to scan your index on call C and it will take 85% of the execution. So a scan again will check every single index row in the table. What's the point of having index? The point is when I query on the table, I want to fastly point to that records for finding the result. But here it has to scan the index. What's the point? The point is still, I want to emphasize this, right to left. It means if I remove the first wildcard here and it try to find every row that started with C sharp, SQL Server will use the index. Let's see. Here we can see this lovely index seek. So a starting point is important. For example, in the C sharp and the entity framework, if you change link to start with like that, it will translate to this query and this good. So in case of wildcard or like in the SQL Server, it will not use the index only in this case with start. For example, this case not using the index and also this case not using the index. That's it. I hope you get the point of SQL Server and how it uses the indexes when it wants to run the query. Thank you very much for your time. Bye.